Hello, everybody. All right, so we're going to continue with our chapter 11 discussion. I think at the end of my last video, I said actually we were going to continue with triangles. I don't know what I was thinking, but anyway, we're working on quadrilaterals today. So, in our essential question is how can you classify and compare quadrilaterals? And again, we've been working with identifying quadrilaterals since at least third grade. So, we should be becoming more familiar with the terms and the definitions for each of these different quadrilaterals. So let's look at the unlock the problem. We are on page 473 of the fifth grade Go Math textbook. So a seating chart for a baseball field has many four-sided figures, or quadrilaterals. What type of quadrilaterals can you find in the seating chart? Well, there are 5 special types of quadrilaterals. You can classify quadrilaterals by their properties, such as parallel sides and perpendicular sides. Parallel lines are lines that are always the same distance apart. Perpendicular lines are lines that intersect to form 4 right angles. So let's go through each of these. So complete the sentence that describes each type of quadrilateral. All right, so a general quadrilateral, something that has 4 sides and 4 angles. 1, 2, 3, 4. 1, 2, 3, 4 angles. All right, so that's general. Any four-sided figure can be called a quadrilateral. So one name is a parallelogram, and it has opposite sides that are congruent and parallel. So the congruent marks tell us that this side and this side are congruent, or the same length. This side and this side are also congruent. So when we say opposite sides, this side is opposite from this side. This side is opposite from this side. All right, so parallelogram. Opposite sides that are congruent and parallel. All right, so a rectangle is a special parallelogram. Okay, we see that the opposite sides are congruent. Opposite sides are congruent. Okay, and they're also parallel. They're the same distance apart. So a parallelogram with, however, is special because it has 1, 2, 3, 4 right angles and 4 pairs of perpendicular sides. Okay, 4 perpendicular sides, meaning creating 4 right angles. A rhombus is also a special parallelogram, and it has 4 congruent sides. Okay, so when we look at a rhombus, we see 1, 2, 3, 4. All 4 of those sides are equal. This particular rhombus does not have 4 right angles. So a square is a special parallelogram with 4 congruent sides, just like a rhombus, but it has 4 right angles, like a rectangle. So a square technically can be called a rectangle and a rhombus, as well as a parallelogram. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. Okay, if it has 2 parallel sides, it cannot be a trapezoid. So here, those 2 sides are parallel. Okay, so the types of quadrilaterals you can find in the seating chart of the field are, all right, well, let's look at this section right here. Well, that's a parallelogram, right? It's a rectangle. Okay. Do we see any other shapes? Well, this middle section way out here is a trapezoid because this side and this side are parallel. Okay, do we see any rhombuses? Well, technically, if I look at the diamond, the infield, that's a rhombus. It also has 4 right angles, so it could be a square too. So basically, all of those shapes can be found in this seating chart that they're showing us. Just by the square has all of those names. A square, is a parallelogram. It has opposite sides that are congruent and parallel. It's a rectangle because it has 4 right angles and 4 pairs of perpendicular sides. It's a rhombus because it has 4 congruent sides. It's a square because it has 4 congruent sides and 4 right angles. It is not a trapezoid. So the square is the only name that you couldn't give a square is trapezoid because it has 2 pairs of parallel sides. But there is a trapezoid in the drawing, right? This out here is a trapezoid. All right, so let's look at page 474. Now, I need to admit that I'm not quite sure what they mean by cut out the quadrilaterals and sort them into the Venn diagram. So what I'm going to do is just go ahead and draw things that would be appropriate for each of the boxes. Okay. So parallelograms. So parallelograms do not necessarily have to have equal sides. So I want to draw a parallelogram and give examples of parallelograms that are rhombuses, rectangles, and squares, and then parallelograms that don't fit in anywhere there. Okay, so basically, I know that if none of the sides are equal, I'm sorry, if it has 2 pairs of congruent sides and 2 pairs of parallel sides, it's a parallelogram. A rhombus would be equal sides. So if we go something like 10, and 10, so if I make all sides 10, it's basically a rhombus, right? A square that could be both a rhombus and a rectangle, again, would have equal sides. But we know the square has to have right angles. A rectangle would have the 4 right angles and opposite sides that are congruent. Okay. A trapezoid would have 2 sides that are parallel. All right, so something like that, right? All right, so a square is both a rhombus and a rectangle. Trapezoids are not part of this because they don't have 2 pairs of parallel sides. All right, so let's look at these questions here. A rhombus is always a square? No, if it doesn't have right angles, it's not a square. So sometimes. A rhombus just simply has to have 4 equal sides. A square has to have right angles. A parallelogram is blank a rectangle. Always, right? Oh, no, I'm sorry. No, I can have a parallelogram that doesn't have right angles, right? Yeah. So sometimes is a rectangle. A rhombus is always a parallelogram. No matter if it has right angles or just 4 equal sides, it's still going to have 2 pairs of parallel sides. So a trapezoid is never a parallelogram because it only has 1 pair of parallel sides. And a square is always a rhombus. All right, number 1. Explain why the circle for parallelograms does not intersect the circle for trapezoids. Well, trapezoids are not parallelograms. 2. Explain why the section of the Venn diagram for squares intersects with both the section for rhombuses and the section for rectangles. Squares are both rectangles and rhombuses. All right, let's look at 475. So use quadrilateral A, B, C, D to answer each question. Complete the sentence. Measure the sides. All right. Are any of the sides congruent? And mark any congruent sides. So side AB is 25 millimeters. Side DC is 27 millimeters. Side CB I'm going to say 19 millimeters. And side AB is also 19 millimeters. Let me redo AB just to double check. Actually, I'm going to change AB to 27. All right, so we have those two equivalent and those two that are equivalent. So 1A, are any of the sides congruent? Yes. Okay. These opposite sides are congruent. How many right angles, if any, does the quadrilateral have? None of these are right angles. This is an obtuse angle, so A and C are obtuse, so opposite angles are similar, and B and D are acute angles. So it doesn't have any right angles. How many pairs of parallel sides does the quadrilateral have? AB is parallel to CD, BC is parallel to AD, so it has 2 pairs. So what's the name that we would give this? Well, it's not a square. It's not a rhombus because all 4 sides are not equal. It's not a trapezoid because it has 2 pairs of parallel sides. So it's a parallelogram. All right, now classify these in as many ways as possible. Okay, we know this shape's a quadrilateral because anything with 4 sides is a quadrilateral. It's a parallelogram because it has opposite sides that are parallel. It is a rectangle because it has 4 right angles and opposite sides that are parallel. It is not a rhombus because all 4 sides are not congruent. It's not a square because all 4 sides are not congruent. And it's not a trapezoid because it has 2 pairs of parallel sides. So these 3 names can be used for that shape. Number 3, it is a quadrilateral, has 4 sides. It is not a parallelogram because these sides are not parallel. It is not a rectangle because it's not a parallelogram. It's not a rhombus because it's not a parallelogram. It's not a square because it's also not a parallelogram. It is a trapezoid because it has exactly 1 pair of parallel sides. All right, number 4. Classify the quadrilateral in many ways as possible. Right, quadrilateral, parallelogram, rectangle, rhombus, square, or trapezoid. Okay, we know it's a quadrilateral, has 4 sides. It is a parallelogram because the opposite sides are parallel. It is a rectangle because it's made up of 4 right angles. It is a rhombus because it's showing me that all 4 sides are congruent. It's a square because all sides are equal and it has 4 right angles. It's not a trapezoid because, well, trapezoids aren't parallelograms, and this is a parallelogram. Number 5, it's quadrilateral, 4 sides. It is not a parallelogram. It doesn't have 2 pairs of parallel sides. It's not a rectangle. It doesn't have 4 right angles. It's not a rhombus because it doesn't have 4 congruent sides. It's not a square because it doesn't have 4 congruent sides. It is a trapezoid. It has opposite sides that are parallel. Exactly 1 pair of parallel sides. Number 6, quadrilateral. It is a parallelogram. It has 2 pairs of opposite sides that are parallel. It's not a rectangle. There aren't right angles in it. It is a rhombus because all the sides are equal. It can't be a square because there are no right angles. And it's not a trapezoid because it's a parallelogram. Okay. Number 7, quadrilateral. It is a parallelogram. Opposite sides, 2 pairs of opposite sides that are parallel. It is not a rectangle because it doesn't have 4 right angles, which also eliminates a square. It's not a rhombus because all 4 sides are not equivalent. And it's not a trapezoid because we already called it a parallelogram. So those are the only 2 names for this shape. All right, page 476. Number 8. So a quadrilateral has exactly 2 congruent sides. Which quadrilateral types could it be? And which quadrilaterals could it not be? Well, it could be a quadrilateral. And if it only has 2 congruent sides, has exactly 2 congruent sides, just quadrilateral. Maybe a trapezoid. Could be a trapezoid. Well, it can't be a square. Squares have 4 congruent sides. Can't be a rhombus. Rhombuses have 4 congruent sides. Can't be a rectangle because rectangles have more than 2 congruent sides. Rectangle is going to have 2 pairs of congruent sides. So it can't be a rectangle. And it can't be a parallelogram, because if it can be a trapezoid, it can't be a parallelogram. All right, number 9. A quadrilateral has exactly 3 congruent sides. Davis claims that the figure must be a rectangle. Why is his claim incorrect? Use a diagram to help explain your answer. Okay, well, the 4th side may not be parallel with its opposite side. So it could be a trapezoid. For example, trapezoid. So what would that look like? Well, we're saying that 3 of the sides are equal. So we could have 10. We could have 10. And okay. So looking at this, actually this is 4 congruent sides. Okay. But even looking at this one, it had 3 congruent sides, but it's not a rectangle. None of the angles are right angles. Okay. Let's try another shape. So let's see. 10. No, sorry. Let's make that 15. Then make this 15. There's no way to really do it. Okay. So we're going to ignore that middle line there. I kind of messed that up. But so these are 15. Okay. All 3 sides are 15. But when I close this top side is only 10. So this is 10 millimeters and everything else is 15. So is that a rectangle? No, because these 2 sides are not congruent. Okay. But I could call it a trapezoid because these 2 sides are parallel. All right, number 10. The opposite corners of a quadrilateral are right angles. The quadrilateral is not a rhombus. What kind of quadrilateral is this figure? Explain how you know. So, could be a rectangle. Okay, because it can only have This is basically what they're telling us. So the opposite sides, the opposite corners, sorry, are right angles. So opposite corners are right angles. Opposite corners. Okay. But the sides are not equal. So if the sides are not equal, it can't be a square. It can only be a rectangle. All right, number 11. I am a figure with four sides. I can be placed in the following categories. Quadrilateral, all right. Parallelogram, so that means opposite sides are parallel. It can be a rectangle, so that means it has to have four right angles. It can also be called a rhombus. That means it has equal sides. Well, if it has equal sides and it can be called a rectangle, that means it's a square. And it's a square. So draw me. Explain why I fit into each category. Okay, so all sides have to be equal. So I'm going to make a four-sided figure that is 10 millimeters on each side. Okay. And so here's a parallelogram. Because it has two pairs of parallel sides. It's a quadrilateral. Because it has four sides. It's a rectangle. Because it has four right angles. It's a rhombus because it has four equal sides. And it's a square because it has four congruent sides and four right angles. Okay. So basically we're having to explain why a square has five different names. It's a parallelogram because it has two pairs of parallel sides. It's a quadrilateral because it has four sides. It's a rectangle because it has four right angles. It's a rhombus because it has four equal sides. And it's a square because it has four equal sides and four right angles. Right. 12a through 12c. Write the name of one quadrilateral from the tiles on the line to complete a true statement. Use each quadrilateral only once. A blank is sometimes a square. Well, it's not a trapezoid. And a square would be always a square, so it must be a rhombus. And that would be true. If it has four right angles, the rhombus is a square. If it only has four congruent sides, but no right angles, it's just a rhombus. A blank is always a rectangle. Well, a trapezoid is never a rectangle. A rhombus could be a rectangle, but a square is always a rectangle. A square has four right angles. And a parallelogram is never a trapezoid, because trapezoids have exactly one pair of parallel sides, not two pairs. All right, so that's it for our discussion of quadrilaterals. In our next lesson, we'll be talking about three-dimensional figures. So until then, I will see you soon.